Thank you, Dr. Dr. Sri. It is fantastic to join this meeting. So can you guys hear me?
Yes, I can hear you.
Awesome. So I'll try to make it a little shorter so that Anand gets more time. The topic is different. The topic is, I'm going to share my screen now. The topic is how to build an end-to-end AI implementation. So from concept to production, template for the entire ML journey. So my colleague Elvin Zhu, who just joined, he is part of the team, and another gentleman, Alan Gore, who is also part of the team. Three of us have been working on multiple projects together. And as we do customer projects, by the way, my role is program manager within Google Cloud, implementing ML problems, primarily ML. That's my specialty. And so as Elvin, myself, Alan have been working on many projects, we found out that it is difficult and complicated to implement ML projects from end to end. So we decided that it would be great if we came up with a template. So we presented an idea of a template which we have been implementing, and a lot of folks requested that we do a workshop. So we are now putting together a workshop on May 10th and 11th from 9 to 1. And at this conference, we'll be doing a workshop, a hands-on workshop. This is the first time we'll be doing anything virtually, a workshop virtually. So I don't know how that will work, but we'll try. So the idea is for you to start from a concept, a use case, an ML use case. And during this 2-day workshop, take that use case all the way to a productionizable pipeline. And that's a tall order to achieve, but this is something that a lot of people have been trying to do, because most ML problems never see the light of the day, because at the initial implementation, you write some beautiful Python code, you solve your problem, write an ML project. But as has been famously said, it's only 5% of the problem. How do you take it to production has been a big challenge. So a separate field has evolved out of this called MLOps. And this whole workshop falls within that category of MLOps. So the title of our workshop is From Concept to Production, Template for the Entire ML Journey. So moving on to the next slide, there is a lot of topics to discuss. So the abstract is basically create a template in Python for the entire ML journey. It will be in 2 parts. On day 1, we start with an example use case, and we build the ML components or a prototype in a Python notebook. On part 2, we will take that notebook and we'll deploy it in a Kubeflow pipeline. The entire project will be implemented in the Google Cloud Platform. However, that's what Elvin and I work with, but it doesn't mean that it has to be restricted in that. You could use it in other clouds, including on-prem. Potential models that can be built are XGBoost, TensorFlow, and scikit-learn. So we'll pick one because I don't think the 2-day workshop will have time for all 3 types of modeling, but we can set loose a few code examples of the others. So these are key links. Moving on, what will you need? You'll need to bring your Google Cloud account if you have it. If you don't, get a free account. The link here, I will release the slides to Lena and you can get access. You can also click on the free link. It is basically cloud.google.com/free. You need to brush up your Python skills. The link over here is a Coursera class from University of Michigan, which is an excellent class for Python for data science. You need to brush up on your TensorFlow ML modeling skills, which are there in the tensorflow.org site. And you need to brush up on Kubeflow pipelines, which is there in kubeflow.org site. So those are all linked over here. So these are some of the prerequisites. These are the 4 prerequisites. We have a month to get ourselves familiar with that. It would be fantastic to have prior knowledge. We don't want to learn Python while we are implementing something in Python. So what is our vision? We start from your use case. We want to integrate an existing ML model, or we want to build something from scratch. We want to automatically deploy an end-to-end ML pipeline. We want to create a scalable, composable, secure ML pipeline. And we want to demonstrate the steps on how to implement this. So this is a full ML journey from concept to production. So this is an example of an ML pipeline where the data is coming in through either a real-time source or stored or a repository. Then you do data preparation. You can do hyperparameter tuning. You can do model training. You can do deployment of the model. You can do explanation of the model, and then you predict the model. This whole pipeline has to be orchestrated. One thing we'll not cover in the course is CI/CD, but we'll cover all the other pieces. So what we want to solve is a use case. We'll start from scratch or use a pre-existing model. In this case, we'll start from scratch. We'll take a data set, a public data set, like a loan delinquency data set, or the taxi data set, which is very common public open source data set, and we'll build a model. And then we want this model to be easy to deploy. We want it to be scalable. We want it to be composable. That is, it consists of all these individual pieces. It should be orchestrated and it should be secure. So those are the steps. So this is a pure practitioner's view of machine learning rather than a researcher's view. So we'll do it in 2 steps. On day 1, we'll build a prototype. On day 2, we'll create a ML pipeline. So those are the 2 things: build a prototype and build a pipeline. So on day 1, we'll start from your use case or a use case. We'll make sure your GCP infrastructure exists, and you will have people ready to work on it on the workshop. Then the model, will build a model with acceptable performance. All the modeling pipeline will be tested in the Python notebook, and we will be ready for deployment on the GCP. On day 2, we are going to take this stable model and we are going to automatically create an ML pipeline on your GCP project. GCP stands for Google Cloud Platform. And we'll create a scalable, composable, secure ML pipeline. So those are the 2 steps. On day 1, we'll go from start to your use case to a stable model. On day 2, we'll go from stable model to a deployable pipeline. So the whole journey of machine learning. Here's once again some of the components of the ML model, which is data ingest pre-processing, hyperparameter tuning, model training, model deployment, prediction, online and batch, model explanation, and training orchestration. So we are going to implement all of this as the prototype, then deploy all of this as a Kubeflow pipeline. So going back to the Python notebook. So once again, we'll build the key modules, which is build and train the models, deploy the model, predict the model, and explain the model. And then in this step, we are not going to build the pipeline or orchestrate the pipeline. This is when we are just building the prototype. In the next one, so this is a little deeper dive into each of these steps and how to build the model, how to do the prediction. There's online and batch prediction, 2 separate types. In the training, we have hyperparameter tuning and model training. Deployment of the model is basically you create a metadata and a version for the model and you store it in a repository, in a model repository. And further deeper dive into each of these modules as Python modules we'll build so that we can deploy them in the Kubeflow pipeline. So once again, going back to all the different Python modules, you have the input, you have the training, hyperparameter tuning, training, deploy, explain, and predict. Now, how do you create an ML pipeline? Elvin, thanks for joining. I know you kind of joined in the last minute. Do you want to speak to this topic? It's up to you.
Yeah, yeah. I can take it from here.
Thank you.
Thank you, Chanchal, and hi everyone. This is Alvin. I'm an AI engineer from Google PSO AI service. As Chanchal mentioned, here we want to demo is a machine learning pipeline using Kubeflow and Google AI platform. So basically, as a data scientist, our regular role are always involving like designing different machine learning models using TensorFlow or PyTorch or whatever the tools you or the frameworks you use for building models. But building models is just a part of the job. If we want to try to productionize the model using for our use cases, we have to consider two things basically. So one is how do we scale the models to meet the performance requirement like latency and throughput. That requires you to auto scale your models based on your training jobs or your prediction jobs. And the second thing is orchestration, right? So building models is a core part of machine learning job, but you also have to deal with data processing, augmentations, model validations, and deployment. So there's a lot of like modules inside your machine learning pipeline other than just building model itself. So you need an orchestrator to orchestrate the entire process of pipeline. So to deal with the first problem, we are using Google AI platform training and prediction. So that's fully managed service for your machine learning jobs. So basically, you should focus on what you are best with, like building models, designing the best cutting edge models, and Google will manage the auto scaling for you. So you don't have to worry about setting up your GPU drivers, using how many virtual machines you want to use. You have to configure those numbers. The Google AI platform training will do that automatically for you based on your needs. And that is also true for prediction jobs. When you're deploying a model into GCP, Google can auto scale up and down based on your queries, how many queries per second. So that is Google AI platform. And the other thing is the orchestration that is done by Kubeflow pipeline. So the Kubeflow pipeline cutting each steps like data ingestion, data preprocessing, data validation, visualization, the training model itself, and also the model validation, the deployment of the model into different smaller modules. And each module is orchestrated and based on Kubeflow. So using Kubernetes to orchestrate the entire pipeline for machine learning. So here in this slide, custom ML model with Kubeflow pipeline. In the workshop, we will introduce how to use those tools. So first of all, we need to set up the GCP project in order to use Google AI platform and also the Kubeflow pipeline. So I want to mention the Kubeflow pipeline can be used in any platform, not only GCP. You can use in Amazon or Azure or your on-premise system. But here we just show it on GCP. And the second step is trying to demonstrate how to set up the AI platform pipeline. And we'll also go through create a Python function-based components and also a Docker image-based components. So basically, Python function-based components is a more simple and straightforward way to build your components, and the Docker image-based components is more customizable, require more effort, but it's more flexible. And the following is creating the pipeline with KFP DSL and the final step is uploading the pipeline into a GCP Kubernetes cluster, and we will demonstrate the UI and going through how do you run experiment with your pipeline. So
this is an example of the UI.
We cannot see the UI, we only see the title here.
Oh, you cannot? The slide, you cannot see the slide? Demo XGBoost? Oh,
okay, we can see it now. Yeah, so here is a demo of the UI. You can see a DAG, which is direct graph here, and there's only 2 steps involved in this demo, but we will show you a more complex demo with more steps involved, like data preprocessing, training a model, uploading the model to GCP to serve for inference. And on the right-hand side, you will see the logs for each workers, and you can debug using those informations, of course. And
thank you, Alvin. Yeah. So this is the
you.
day 2 workshop. The day 2 workshop is going to take the prototype and build the Kubeflow pipeline. I also have another pipeline that we created, which is automated. We are not going to cover that in this presentation. In the workshop, we can show you the code. This is a different type of scenario where you already have an ML model and you have a proven ML model, then you quickly deploy the model in a pipeline. So I'm not going to go over these slides. So just to let you know that this is a very interesting course. It is this slide sort of, I'll quickly go to this 1 second. This slide, your entire ML journey sort of summarizes the 2 days, build a prototype and build the pipeline. And it will be very interesting to start from a use case, learn how to build a model, which most of you will probably already know. But what will be new and exciting is how to take that model and deploy it into an ML pipeline. And that will be the 2-day class. And as Elvin said, he's an expert on the Kubeflow pipeline. So he's going to also, we are going to create examples on the ML pipeline. And the other gentleman who will be helping us is Alan Core. I want to give a lot of credit. He will also be helping us out. So that's basically the summary of what we are going to do in the 2 days. And hopefully you'll find this very interesting, that you can take an idea of a ML use case and take it all the way to production and show it in an 8-hour workshop. So you should be able to do that in your own setup in a matter of days or weeks at most, which usually used to take months, if not years, to implement. That's it.
Thank you, Dr. Chanchal Chatterjee.
Thank you, Dr. Sri. Thanks for the kind words, and thanks for inviting me to be part of the webinar. So this is going to be a quick overview or a preview of the talk I'll be giving at the actual Global AI Conference in May 10th to 15th. So I'm the Chief AI Officer of Unscrambl, and we're a startup that's in this newly emerging space of conversational BI and analytics. I'll explain what that means. And I'll also explain why I think there's an interesting definition of Turing test in this space. So firstly, what is conversational BI and analytics? So it's a new paradigm that's emerging where various products can allow users to ask questions of the data using text or voice. So I often call it as an Alexa or a Google, for the matter of, on data. So focused on asking questions related to data. And essentially when you ask a question, the idea is that you get back a natural language as well as visual analysis of interesting results that's interesting for the given user. So you might ask questions about data and get back interesting answers instead of needing to write code in languages like Python or SQL. So that's the key idea behind conversational BI and analytics. So before I jump into details, there's often a confusion that people have in this term conversational analytics. There are 2 definitions that's popularly used. One is around analyzing conversations, and the second is accessing insight and analyses through a conversational interface. So for the purposes of this talk and the talk in the actual conference, I'll be talking about conversational analytics as defined as accessing insights and data analyses through a conversational interface. So the problem that this paradigm tries to solve is that in many organizations, enterprises, as well as in the general public, adoption of data and literacy of data is very low. So all data tends to be concentrated in the hands of a few power users, who could be data analysts or data scientists, and rest of the organization find it very difficult to get access to data. So business users of various kinds may not know the right programming languages, may not know the right tools, may not know how the data is stored, how it is modeled, and how to frame the right queries. So in general, adoption has been pretty low. And in fact, it's actually been decreasing, at least perceptually, in the last few years. The solution is, we want people to be able to play with data themselves. So more power to the people. And this is the whole goal of data democratization, if you've heard that term. Our specific solution is allowing natural language conversations with data within collaboration tools. So we have a bot called Cubo, which stands for Query Bot, and we call it a personal AI-powered data analyst, where you can ask questions like, why did sales drop in a given month? Or what is the revenue last week? What is the revenue by device last week? Why were acquisitions lower in February? The whole idea is that you can ask questions to this bot in natural language, and you'll get back relevant insights, and you can see some charts as well over here, back in the form of natural language and charts. I'll show a very quick demo, and I'll show a much longer demo in the actual talk, but just to give you an idea of what this looks like, this is actually one of the public demos that we have on various sustainability data sets. So I can ask questions like, so in this case, there's data about agriculture, one of the different topics that's the data about. I can ask questions like, what is the cereal yield in India yearly? Right. So behind the scenes, the system is able to understand the question. In this particular data set, there are a couple of ways you can answer the question. There are a couple of different attributes that could be used. But let me pick one of these. Right? And then what happens is that the system is going to essentially pose the question back to a database, get back the answer, present it in a meaningful fashion, and then the user can further tweak how it's presented. So if you want to see, as a chart, you might see this, and you might say, okay, fine. The cereal yield in India has been growing since 1961 to 2017, which is, hopefully a good sign, right? Another question might be, what is the agricultural land in the world yearly? So. And again, there might be a couple of different ways of interpreting it. So the system comes back and says, we actually have two different ways of calculating this. I can do agricultural land, or I can do agricultural land percentage. So that's what Cubo is coming back with. So if I pick yearly here, if I pick the first one, agricultural land, again, get a bunch of data. And again, I can see it as a line chart, or as a bar chart, or as an area chart in this case. And, we might observe some interesting things over here. So for instance, that the agricultural land increased dramatically in 1992. So as a bot, you could ask some questions to dig into that. So one of the ways of framing that question is, why is the agricultural land in 1992 more than 1991 in the world? So this is a more deeper, question where we're going, not just it's not a simple SQL query, but we're asking for a sort of a root factor analysis or root cause analysis of what went on between 1992 and 1991. And in this case, one of the things that comes back with is a bunch of interesting things about it goes into different countries and regions and comes back with an analysis of what happened between those two dates. So in the actual demo, I will dig deeper into, and we can actually go at a country level, we can go at a region level, we can go and see exactly what changed between those 2 points in time. So that's the bot we built. So while we're building this bot, one of the questions that that we've been posing to ourselves is this AI, right? And very often people have questions, what is AI? And the general definition of AI tends to be in the form of Turing test. Can a given system imitate a human, right? So in the case of conversational analytics, the Turing test can be defined as, can a conversational analytics bot be indistinguishable from a human data analyst or potentially even a human data scientist? Right. So, and if the answer is yes, then we could say potentially that this is AI. Although even the definition of AI keeps changing almost every year. So we've gone a bit deeper into this particular question. Now, what does a human data analyst do, or what does a human data scientist do? And we got a very good sense of the whole pipeline of data analysis and data science in the previous talk from Chanchal. So now, what would a bot have to do to be able to behave as a data analyst or a data scientist in an organization? Right. So, and we came up with a few different themes over here. And in this case, one of the key things a data analyst or data scientist does is to actually listen to requirements from business users. Some of those requirements might be very poorly formed, might be ambiguous, and they need to clarify them. I'm sure Chanchal went through that whole phase when he was working with his with his customers that he mentioned. Then data scientist, data analyst might retrieve data, analyze it, might present results to the users, explain it in some fashion, might collaborate with the users to refine those insights, might learn the business users' preferences and how they like to see the results and what makes sense to them and what's interesting to them, and might even proactively tell the user about interesting insights and not just wait for a user to ask. So here's some of the behaviors that we think a data analyst might show on a day-to-day basis in an organization. And those are some of the things that a conversational analytics bot might also need to emulate if it wants to be considered as AI. Right, so let's dig into a few of these, at least in this talk, and then again in the actual conference, we'll go deeper. So one of the things that we often see is that business users might ask ambiguous questions. So this is actually a real example from an insurance customer where people might ask questions like, how many policies were there last year? So, and the different ways of interpreting that, right? So the bot, in fact, might come back and say, did you mean how many policies were issued last year or how many policies were active last year, which could have different meanings. So the point of a personal data analyst is that it should be able to recognize, he or it or she should be able to recognize ambiguities or different possible interpretations of a natural language question or of a poorly formed question, and come back with clarifications. So that's one of the behaviors that we think a bot should have in this space. Another key thing is that business users do not know what data exists. So they're going to form questions the way they want to form questions. So this is like a biking data set, let's say, where a user might ask questions like, what's the number of rides by age group? Or what's some jargon, ADPU in the last 6 months? So ADPU stands for average duration of a trip per user. The actual data model might say nothing about rides or ADPU, but it's the job of the data scientist to figure out how to bridge the semantic gap and how to map concepts that a business user might know or understand to actual concepts or actual terms or attributes that might be present in the physical data model. And so that mapping is something that the bot would need to do if it wants to be considered AI. Another thing that bots might need to do is to collaborate with users and iteratively analyze data. So for instance, this is sort of an in-depth conversation where a user might ask, how many bike trips were there in New York City? The bot might come back with a number, 82.63 million. And the user might say, how many in Jan? The bot responds, how many were longer than 50 minutes? Show me by age group. What is the top start station? What is the top start station of those trips based on total duration? How many trips end in that start station or in that particular station? So a typical data analysis task is not just a one-off question in most cases. It's often a sequence of questions that a business user might ask along with the data analyst to finally arrive at an insight that could be actionable, right? And the bot should be able to support that whole process. Another thing a bot might need to do is to remember previous conversations. So the business user asks, why was I interested in a given station, like 3rd Avenue and 71st Street station last week? The bot might come back and remember this thread of analysis we did last week. This is what we discussed, and this is why this is interesting for you last week. Or another thing a data analyst, a data scientist might do is to work with the user as they go from descriptive to diagnostic to predictive to prescriptive. So go from basic insights to a final decision that they can take or that they can action upon. Bots might also need to be able to collaborate with not just one user, but with multiple users. There might be different users that might need to work with the same bot to come up with some joint decisions, which is what often happens in an organization, where you could have a team of different people that work with a data analyst or a set of data analysts. And one more behavior is that a bot might be useful or might find it important to inform users proactively about interesting things. So the bot might say, hey CMO, Chief Marketing Officer, do you know that women above the age of 70 take surprisingly long trips on average, which actually is true in the data that we have. And then the user can say, oh, this is interesting, can you say more? And then the bot might come back with more information. So I'll pause here and go for see if there are any questions. But thanks for your time, and looking forward to seeing some of you in the conference as well.